last video for the week. Tomorrow is your test. You have to do these tests. If you're not doing them, they will become zeros. I have given zeros to a couple students. I am reaching out to those, and I give you a small deadline, but you need to do those quizzes as well as your homework too, because zeros will add up if you miss once or twice a week. Okay, here we're going to learn about calculating midpoint and lengths of segments. Here, example 1, we have some sort of a triangle. According to this, it's talking about streets, talking about different things you can read on your book. Make sure you do have the book in front of you. But here they're asking you what's a direct distance from point P to Q. So they don't give us any numbers, they don't give us any reference. They're not dealing with the actual coordinate grid, so we don't care if they're coordinates or not. But here we want to find the distance between P and Q. This is considered our X. Here we do have our lengths for our two sides. If you look from P to R, if we count the number of units, so 1, 2, 3, 4, we have 4 even units for that triangle. And if we look over here, 1, 2, 3, we have 3 units there. If I were to draw that triangle, I would have 4, 3, and then X. From this, we have to find the distance between those 2 points. To find the distance between P and Q, we use the Pythagorean theorem, and that's what we just learned yesterday. So to apply it, remember, one side squared plus the second side squared is equal to your hypotenuse squared. Sorry, my light's in the way. Now, remember to find and identify your hypotenuse, it's always right across from that 9 degree. So you have 4 squared plus 3 squared is equal to x squared. Now you have 16 plus 9 is equal to x squared. 16 plus 9, I believe, is 25, is equal to x squared. And to get the x by itself, square root both sides. So that means that distance from here to here is considered 5. So we used Pythagorean theorem. What's something that's similar, especially when we're dealing with the coordinate grid, which we will with different coordinates, is the distance formula. It's the square root of the whole thing. It's very important because a lot of people after the second and third step, they just avoid the square root and they don't square root their answers. So always bring that square root down for everything. It's the second coordinate, second x coordinate minus the first x coordinate squared plus y2 minus y1 squared. And the midpoint here, we're going to deal with that just in a bit, but we're going to focus on distance formula. So here it says find the distance between these 2 coordinates. You're not going to count the number of units because it's going to be a line, it goes directly across. We have to find the exact amount. To find the exact amount, we go ahead and use the distance formula. What I do and what really helps students out is identifying and labeling your coordinates. So let's say this is the first set. I'm going to label it x1, y1. This is my second set, x2, y2. Now I just fill in accordingly. x2 is 6 minus x1 is 3. 6 minus 3 squared. Bring everything down. I promise you, a lot of people make the smallest mistakes for this formula. Y2 is 4 minus y1. Whenever you have negatives, always put parentheses on them. So it's 4 minus negative 2. If I were to rewrite this and make it even simpler, I have 6 minus 3 squared plus 4 plus 2 squared. In the square root of everything. I'm bringing the square root down every time I simplify my steps. Now I go ahead and subtract. 6 minus 3, 3 squared. 4 plus 2, 6 squared. If I keep on simplifying, I get the square root of 9 plus 36. And I end up with the square root of 45. Here, for example 2, they want you to simplify as much as you can. And to simplify the radical, you find one factor of 45 with one of them being a perfect square, which is 9 and 5. Why? Because 9 is a perfect square. This gets simplified to 3 radical 5. Square root of 9 is 3, radical 5, you cannot simplify anymore. Always look for factors of whatever's underneath the radical with one of them being a perfect square. Next one, example 3. Example 3 is where it's kind of difficult because here it says determine whether the quadrilateral is a rhombus. The definition of a rhombus is all sides are congruent. So this is a symbol for congruent, meaning all the sides are the same length. If one side is 4, All of them should be 4. But here we don't have what the lengths are. We have to find the lengths. If you notice, I have all 4 of the equations down here. So let's look at the first one. AB, if you look on your book for that example, AB is that top portion there. The coordinates are this. I'm using the distance formula to solve for these. X squared. So this is my first set. This is my second set. And if you flip them, that's fine too, but make sure this will be your first set, this will be your second set. Always identify one as one set, the second one as the second set. Now you go ahead and simplify here. So x2, 2, minus x1, minus negative 1. Put parentheses over the negatives, squared, plus y2, 1, minus y1, which is 0, and then don't forget the square 2. Moving on to the next step. Take this one step at a time. I can't push it enough how many times people mess up because of the signs. 2 plus 1 squared is equal to 1 plus 0, or 1 minus 0, which is just 1 squared. So I simplified it. 2 minus negative 1, that means 2 plus 1. Keep on simplifying it. You get 3 squared plus 1 squared. And if you keep on simplifying that, 9 plus 1, which is equal to radical 10. That's the length of one side. Next one, DC, you can look on your picture what DC is, but these are the 2 coordinates. My first set, my second set. Now we go ahead and find the square root of it, or find the distance for it. x2, 1, minus x1, it's negative 2. Put that parentheses over it, put it over it. Now, y2, minus y1, which is negative 3. I'm putting parentheses over it. If I'm subtracting, my second number that I'm subtracting should always have parentheses if it's a negative. So these, in this case, there's a lot of negatives. Be careful of your negatives. Now, if you keep on simplifying it, you get 1 plus 2 squared plus negative 2 minus negative 3. It's going to be negative 2 plus 3 squared. Keep on simplifying. I get 3 squared plus 1 squared. That equals 9 plus 1, which equals 10. So 2 out of 4 sides are congruent. Keep on going. Now we have AD. So you can look on your graph from your book to see what the measurement is. My first set, my second set. So x2, negative 2, minus x1, put parentheses around it, squared, plus y2, which is negative 3, minus y1, which is 0, and squared. Keep on going, simplifying step by step. Negative 2, there's 2 negatives, meaning it's positive, squared, plus negative 3 minus 0, it's negative 3 squared. Include those squareds at every step. Negative 2 plus 1 is negative 1 squared plus negative 3 squared, which is equal to 1 plus 9, which is equal to radical 10. Again, all 4 sides have to be congruent. I'm doing this step again. BC, you can look in your book what BC is. These are the 2 coordinates for BC. Am I covering it? No. x1, y1, x2, y2. I apply the formula again, the 4th time, plus that 1 squared. So x2, 1 minus x1 squared plus y2 minus y1. Go ahead and simplify that. 1 minus 2 is negative 1 squared, plus negative 2 minus 1 is negative 3 squared. Go ahead and simplify that even more. Negative 1 squared is positive 1. Remember, when you have 2 negatives, when you're multiplying, you end up with a positive answer. So 1 plus 9. So negative 3 times negative 3 gives you positive 9. And this equals radical 10. All 4 of these have congruent sides. They are radicals, but they are the same exact measurement. This is a rhombus. That would put in the end? Yes. It's a rhombus. All right. Midpoint formula, that means I call it the halfway mark. They want to find the midpoint segment of 2 coordinates. That is, and this is a very easy formula. You add up the x coordinates, you divide by 2, comma. You add up the y coordinates, you divide by 2. Your answer is going to be in coordinate form. Here you have 3, 5, and 7, 2. They want to find the midpoint for each one. To find the midpoint, You add up the x coordinates. You have 3 and you have 7, divide by 2, comma, you add up the y coordinates, that means the second numbers of each one. 5 plus 2 divided by 2. And when you simplify it, 3 plus 7 is 10 divided by 2. 5 plus 2 is 7 divided by 2. And you keep on going. 10 divided by 2 is 5, 7 divided by 2. 5 plus 2 is 7, 7 divided by 2, just want to see if I have this right. I put the numbers in wrong, it's negative 2. So 5 plus negative 2, and that would be 3. That's where I got it wrong. And then that's where you get the 3 over 2, and that's your halfway mark, that's your midpoint. It's exactly halfway from those two coordinates. Example 5, it's a word problem. You can go ahead and read it in your book, but I have to keep on going for the sake of the video and the time of it. You have two coordinates. They want you to find the distance between the two coordinates. So to find the distance, you have to use the distance formula. Identify 1 as your first set. Identify 1 as your second set. Normally I would write it down, but for the sake of my markers, they're running out. I'm not going to rewrite the formula. But for you, I advise you to rewrite the formula every time so you don't mess up. According to the formula, it's x squared minus x, or second x minus the first one. So the second x is 50 minus the first x, which is 30, squared, plus the second y, which is 40, minus the first y, which is 10, squared. Keep on simplifying. 50 minus 30, 20 squared. 40 minus 10, and positive 30 squared. Now, keep on simplifying step by step. 20 squared is 400. 30 squared is 900. And you end up with 1,300. And now here you want to simplify even more. They do want an exact number, so you would have to find the square root of 1,300, and you end up with around 36. And for example, they're looking for how long it is, and it's 36. It's an estimate about 36 yards because they want it to the nearest yard. All right, if you have any questions, make sure to go down there and ask me. Bye.